And here's the estimate. It's a rough estimate. 6,000 to 12,000 kids in Flint were exposed to unsafe levels of lead. And as many people say, it's hard to imagine that would happen in today's day. From the Center of Disease Control, to give you some perspective on how much lead is not safe, they estimate about 500,000 kids have blood levels above this critical 5 micrograms per deciliter. Now, some of that's from eating old lead paint, some of that's from having lead in the water, but this is really key. There is no safe blood level for lead for kids. That is, we have the setting of 5, but we don't even think that 1 is safe based on lots of experiments that have been done and probably things like lab rats, lab mice, etc. And lead exposure is so rampant in what it can do to your body. All sorts of things, as you see here: headaches, aggressive behavior, hard to sleep, all kinds of pain, poor appetite, and especially with kids. I mean, the big things with kids that people are worried about is that these are long-term effects. We can see reduced IQ later in life, behavioral problems, criminal problems, all sorts of things are associated with having lead in the water. And those kind of problems, you think about the amount of cost that's going to be down the road for the next few decades to society from this exposure of 6,000 to 12,000 children. So what can you do? Well, boiling doesn't do anything. That doesn't take lead out of the water. You'd have to find a way to filter lead out of the water. So, of course, the immediate reaction is bring lots of bottled water. And you can look up stories of this. There have been so many corporate donations, private donations of water, truckloads and truckloads of water to help these folks out in Flint. The state of Michigan, after saving that $5 million in Flint, has now sent $28 million in aid. They budgeted another $30 million to help the residents of Flint. President Obama has authorized FEMA and Department of Homeland Security to assist in this crisis as well. And I think what's also helpful, I provided this to you, a nice link that gives you a whole timeline of events, so what unfolded and what the different decisions were and who the different people were involved, from the governor of Michigan to the local officials. And all of that is really interesting to show your students as well. So I think this is, as I said, a really good teaching moment, a tragedy that should have never happened, but a good teaching moment to get people understanding why we should care about environmental science, why we should study environmental science. And I just want to mention there's lots of sources of information. You know this if you have our book already, but for example, there's a whole chapter on water pollution, teaching students a lot of these different issues, everything from things like other heavy metals like arsenic. A lot of people don't realize arsenic is rampant in water, particularly out west, at levels that are really unsafe in the water, up to 50 micrograms. I think 10 is what's considered safe currently for arsenic. Mercury emissions, who produces them, where do they go, et cetera. The economic development in Asia is certainly causing a lot of mercury emissions currently. So things like what's in your stream water, what's the frequency of detection of things that you wouldn't necessarily think about, like steroids, antibiotics, reproductive hormones, are in a lot of streams. And you can see here from like 30 to 90% of our streams are carrying various chemicals, and many of them work on our bodies at incredibly low concentrations, which is why we have to worry about those things coming in. We also have this other chapter on a related note on human health risks, and where we actually talked about how we understand toxicology. How do we understand what level is safe and what level is dangerous, whether it's lead or anything else? So, for example, we talk about the different risks of various things killing you in a nice infographic here, everything from earthquakes and lightning to strokes and heart disease. But we also think about things like pesticides accumulating through food chains and food webs, and the classic story of DDT. And then we tell students about how you actually figure out what's safe and what's not safe. How do you figure out things like an LD50, the lethal dose that kills 50% of a population, like lab rats or lab mice? And from there, how do you figure what's safe for humans? What's the safety factor that we build into that? And then finally, we talk about risk assessment, which is very much what people go through, whether it's Flint or anywhere else. That is, we try to assess the risk and characterize, from these LD50 experiments, what level is safe. But then what people often don't realize is that goes through another step. How much risk are we willing to accept? And then how do we balance that risk against the desires of private citizens, industry, jobs, economic growth, different interest groups? So the level that we often set as safe isn't really safe. It's often a compromise between economic interests and environmental or human health interests, which why, for example, is why arsenic is currently set at a level of threshold that's actually much higher than most scientists agree is safe. So it takes you through that process to help the students understand how we get to figure out what's safe in lead in Flint water or anybody else's water. So I think those are really helpful aspects of the book to bring the students up to speed on these kind of issues. So I don't want to take a lot of your time, but I wanted to sort of provide you with this information to maybe be a teaching moment for your students about the Flint water, emphasizing how important fresh water is, and really it's fresh, clean water that's in really short supply. This is a great example of how citizens and scientists in Flint have worked together. What really blew the story, the top off of this story is a physician, and you can read about her. And she did a great job of going out and testing, I think it was about 1,700 people's blood to see how much lead was in their blood. And for a while was chastised by government officials, et cetera, but eventually it came out that she was right. These neighborhoods had high lead, dangerously high lead, and that was an example of citizens and scientists coming together. And again, lots of great other stories like this. And you can bet that Flint, Michigan will be in the next edition whenever we get to write the third edition of the APES textbook. So with that, I'd be happy to take any questions you have. Thank you so much for joining us. I appreciate you taking the time from your busy schedules to listen to me and hopefully learn a little bit about the Flint water crisis. And I will turn it over to Nicole to moderate the questions.